Technology has transformed the modern kitchen into a space where creativity, precision, and convenience work together. Home brewers, cooks, bakers, and culinary experimenters now use smart devices to measure ingredients, monitor preparation, and improve the consistency of their recipes. By understanding how these products are used, maintained, upgraded, reused, and recycled, households can benefit from smart kitchen technology while making more responsible decisions throughout its life cycle. Modern kitchens may include smart coffee makers, digital thermometers, electronic kettles, precision timers, fermentation controllers, connected scales, and ingredient analyzers. These devices reduce guesswork by collecting information that would be difficult to measure through observation alone. Digital readings allow users to monitor temperature, weight, preparation time, and ingredient quantities with greater accuracy. Connected scales have become especially useful for home brewers and bakers. They can synchronize with mobile applications, store measurements, guide users through recipes, and automatically calculate ingredient ratios. Ingredient analyzers provide information beyond simple weight. Depending on the device, they may estimate nutritional values, compare portions, organize ingredients, or connect measurements with digital recipes. Technology does not replace culinary knowledge or personal experience. Instead, it provides information that helps users apply their skills more consistently. As kitchens become increasingly connected and data-driven, the devices used within them should be treated as electronic products. Their sensors, processors, displays, batteries, and wireless components require thoughtful management when the equipment is no longer useful. Accurate measurements can significantly affect the outcome of coffee, tea, baking, fermentation, and homemade beverage preparation. In coffee brewing, the ratio between coffee grounds and water influences strength, flavor, and extraction. A connected scale helps users reproduce a successful ratio instead of relying on visual estimates. Tea preparation can also benefit from consistent measurements and timing. Digital tools allow users to measure loose tea, monitor water quantities, and control steeping periods more carefully. Baking requires precision because ingredients interact in ways that affect texture, structure, appearance, and flavor. Small differences in flour, sugar, yeast, salt, or liquid can change the final result. Connected scales may include built-in timers, automatic calculations, and wireless communication. Combining weight and timing in one device reduces the need for several separate tools and creates a more organized workspace. Saved measurements allow users to compare different preparation methods. They can identify which ingredient quantities, temperatures, and timing combinations produce the best results. This information transforms experimentation into a repeatable process. Instead of starting from the beginning each time, users can build upon their previous results and refine their recipes with greater confidence. Connected kitchen scales may appear simple from the outside, but they contain sophisticated electronic components. Load sensors detect pressure placed on the weighing platform. These sensors convert physical pressure into electrical signals that can be interpreted by an internal processor. The processor calculates the measurement and sends the result to a digital display. Depending on the model, the display may also show measurement units, timing information, battery status, connection status, and automatic calculations. Bluetooth or Wi-Fi modules allow the scale to communicate with a smartphone or tablet. A connected application may store recipes, save measurement histories, calculate brewing ratios, or guide users through preparation steps. Calibration systems help ensure that measurements remain accurate. Excessive weight, rough handling, unstable surfaces, moisture, and improper storage can interfere with calibration or damage sensitive load sensors. Different scales are designed for different purposes. A coffee scale may focus on small quantities and detailed measurements, while a general kitchen scale may support heavier ingredients with less sensitivity. Because connected scales contain sensors, processors, memory, displays, batteries, and communication modules, they should not be treated like ordinary utensils when they are retired. Their electronic construction requires responsible end-of-life management. Ingredient analyzers expand the information available during meal preparation and culinary experimentation. Some analyzers estimate nutritional content based on the type and quantity of ingredients being measured. Users may review calories, protein, carbohydrates, fats, or other estimated nutritional values. Other systems connect measurements with digital recipe platforms. As ingredients are added, the device may record quantities, monitor portions, or guide the user through individual preparation steps. These features can support meal planning and help users divide recipes into more consistent serving sizes. They may also assist culinary hobbyists who want to compare different versions of a recipe. The reliability of the information depends on proper use. Selecting the wrong ingredient in an application, using an unstable surface, or failing to calibrate the equipment can produce inaccurate results. Ingredient residue should be removed from weighing surfaces because buildup can affect both cleanliness and measurement quality. Many advanced features also depend on software, mobile applications, and online databases. If a manufacturer stops supporting an application, some functions may become unavailable even when the physical device continues working. The primary measuring function may still be useful without connected features. Before replacing an analyzer, users should determine whether it can continue serving its essential purpose offline. Smart kitchen equipment is often replaced because technology advances, not because the product has completely stopped functioning. Manufacturers regularly introduce devices with more sensitive sensors, faster processors, brighter displays, improved applications, and expanded wireless connectivity. These changes can make older equipment appear outdated. Software compatibility is one of the most common challenges. An application may stop receiving updates, or an older device may no longer connect properly with a newer phone or operating system. Wireless standards also change. Older Bluetooth or Wi-Fi components may become less reliable when used with current networks and mobile devices. However, a lost connection does not always eliminate the device's primary value. A scale that no longer communicates with an application may still provide dependable measurements through its display. Consumers should separate necessary improvements from optional conveniences. Greater accuracy, better safety, or improved reliability may justify an upgrade. A different appearance or rarely used feature may not. Testing, recalibrating, changing batteries, and reviewing the operating instructions may correct problems that initially appear permanent. Obsolescence does not automatically mean that a product has no value. Continued offline use, donation, repair, or transfer to another user can prevent functional equipment from entering the waste stream too early. Load sensors, microprocessors, digital displays, memory components, wireless modules, calibration systems, and batteries work together inside connected kitchen devices. Load sensors detect weight, while microprocessors interpret the information and perform calculations. Digital displays communicate the result to the user. Memory components may store preferred units, measurement histories, recipes, or personal profiles. This information should be reviewed before a device is donated, transferred, or recycled. Wireless modules provide communication with mobile applications and online systems. These components increase the functionality of the product, but they also increase its electronic complexity. Some devices use replaceable batteries, while others contain rechargeable batteries. Battery condition affects performance, operating time, safety, and end-of-life preparation. A compact kitchen scale may contain plastic, metal, glass, wiring, circuit boards, sensors, and battery materials. These materials cannot always be managed through the same process. Licensed recyclers can evaluate the complete device and direct its components toward appropriate forms of processing. Routine maintenance can preserve accuracy, improve reliability, and reduce unnecessary replacement. Scales and analyzers should be cleaned after use. Flour, coffee grounds, oils, liquids, and other residue can collect around buttons, seams, sensors, and weighing platforms. Removable trays can often be cleaned separately. The electronic base should not be submerged in water unless the manufacturer specifically identifies it as waterproof. Moisture entering the housing can damage circuit boards, displays, sensors, and battery connections. Spills should be cleaned promptly and carefully. Scales should never be loaded beyond their stated weight capacity. Excessive pressure can damage load sensors and permanently affect measurement accuracy. The device should be used on a stable and level surface. Movement, vibration, or an uneven countertop can cause inconsistent readings. Proper storage is also important. Precision devices should be protected from humidity, temperature extremes, impacts, and heavy objects placed on the weighing surface. Replaceable batteries should be changed when performance declines. Rechargeable devices should be charged according to manufacturer recommendations. These simple practices can keep connected kitchen equipment dependable for years, allowing households to receive more value from every purchase. The complete life cycle of a smart kitchen device includes its accessories: charging cables, power adapters, calibration weights, removable trays, protective cases, wireless receivers, and storage containers may remain useful after the primary device is replaced. Power adapters should be clearly labeled because similar-looking adapters may provide different electrical outputs. Using the wrong adapter can damage equipment or create a safety concern. Calibration weights should be stored carefully so they remain accurate. They allow users to test whether a scale is producing dependable measurements. Protective cases shield displays, sensors, and weighing surfaces during storage and transportation. Using them can prevent damage that would shorten the life of the equipment. Original manuals explain cleaning, calibration, charging, connection, troubleshooting, and reset procedures. Keeping the instructions with the device can increase its usefulness during donation or resale. Before recycling a damaged device, evaluate each accessory separately. Compatible cables, trays, adapters, cases, and calibration tools should not be discarded automatically. Organizing accessories reduces duplicate purchases and ensures that useful components remain available for future equipment. Before purchasing a replacement, determine whether the current device still meets everyday needs. A well-maintained scale may continue delivering accurate measurements even if it lacks the latest application or wireless features. Recalibrate the equipment, replace its batteries, and test it on a stable surface before deciding that it has failed. A minor operating problem may have a simple solution. If a repair is available, compare its cost with the quality, age, and expected remaining life of the device. Replacing a battery connection or charging component may be more responsible than purchasing an entirely new product. When evaluating replacement options, prioritize durability, measurement accuracy, battery serviceability, and maintenance requirements. Consider whether the product's essential functions will remain available without an application or internet connection. Heavy dependence on software may shorten the device's practical life. Accessory compatibility should also influence the decision. A replacement that accepts existing trays, cables, adapters, or calibration weights can reduce additional purchases. Before upgrading, decide what will happen to the previous device. Working equipment may be donated, sold, transferred, or used elsewhere. Non-functional equipment should be directed to licensed recyclers. When continued use or repair is no longer practical, proper preparation makes equipment easier to reuse, transfer, or recycle. Begin by cleaning all food contact surfaces and removing ingredient residue. Clean devices are safer to inspect, handle, transport, and process. Separate detachable trays, cases, adapters, chargers, wireless receivers, and calibration weights. Determine whether any of these accessories can remain in use. Remove replaceable batteries when the product allows it. Damaged, swollen, or leaking batteries require additional care and should not be mixed loosely with other electronics. Disconnect the device from phones, tablets, wireless networks, and online accounts. Delete personal profiles, stored recipes, and measurement histories when possible. Use the factory reset option if one is available and appropriate. This can remove customized information before the device changes ownership. Protect displays, sensors, weighing surfaces, and loose components during transportation. Cables and accessories should be secured so they do not become separated. Before delivery, contact a licensed recycler to confirm accepted products and preparation requirements. A sustainable smart kitchen begins with thoughtful purchasing and continues throughout the life of every electronic device. Select equipment based on features that provide genuine everyday value. Measurement accuracy, durability, reliability, and ease of maintenance should receive priority. Keep devices clean, calibrated, properly charged, and safely stored. Preventive care can protect sensitive components and delay replacement. Continue using dependable equipment when it still performs its essential purpose. A device does not need every current feature to remain useful. When an upgrade becomes necessary, find a responsible destination for the previous product. Donation and reuse can extend the life of functional equipment. Licensed recyclers should manage scales, analyzers, sensors, and accessories that no longer have a reasonable continued use. Every purchasing, maintenance, repair, reuse, and recycling decision affects the amount of electronic waste a household generates. By treating connected kitchen tools as long-term investments rather than short-term gadgets, households can continue benefiting from technological innovation while conserving valuable resources. When connected kitchen scales, ingredient analyzers, and other smart culinary devices reach the end of their useful lives, responsible recycling can help keep their electronic materials out of the general waste stream. Contact us to learn more about properly managing outdated, damaged, or unwanted kitchen electronics. Measure every ingredient carefully and the impact of every electronic choice.